Okay, here comes problem 7b. 7a was using Euler's method to find an approximation, and if you used your calculator, you'd get 0.825. I'm going to show 7a in a separate video, doing it both by hand and with a calculator, so you can see both ways. But right now, I'm going to focus on solving the problem by separating variables, so solve the differential equation. So we're not going to get an estimate, we're actually going to solve it and get an exact answer. So let's see if we can separate our variables. I'm going to multiply both sides by dx. So the dx is going to end up here. So I have dy is equal to x e to the y dx. Now to get my y to the other side, I'm going to have to divide both sides by e to the y. So dy, and instead of putting it on the bottom here, I'm going to put it on the side 1 over e to the y is equal to x dx. Now, this side is simple enough to integrate because my next step is to integrate both sides, x dx. But looking at this, I'm not used to seeing a 1 over e to the y, but I can rewrite this as e to the negative y because that's the same thing as dividing by e to the y. Okay, now it looks like something maybe a little bit more doable. All right, let's do the right-hand side first, since that one's easier. So add 1 to my exponent and multiply by the reciprocal of the exponent and add my constant of integration. And then on this side, well, e to the when we integrate e to the x, it's just e to the x. So e to the y will also just be e to the y. The negative, though, we got to think about the chain rule. So this negative, if we were taking the derivative of this, we would have to multiply by -1. So since the derivative is the same as the integral with when you have e, that -1, we can just use the chain rule likewise and just bring the -1 down in front. So this is just going to be -1 e to the negative y. And you could test that. You could say, okay, if I take the derivative of this, e to the negative y is still going to be e to the negative y, but then I got to multiply it by the derivative of negative y, which would be -1. And there's my -1. -1 times -1 would give me +1. So if I take the derivative of this, I end up with this. Okay, so we can go back and forth here. All right, so now I need to get the y by itself. So the first thing I'm going to do is let's get rid of this negative. I'm going to move it to the other side. So I have e to the negative y. So I'm going to multiply everything by -1. So I get -1/2 x squared. And the c, it doesn't matter when I multiply it by a negative because we don't know if it was a negative to begin with, right? But now at this point, let's go ahead and figure out what c is. Let's find it because we do have a value for x and y. So here's my x and here's my y. So let's go ahead, substitute in for x and y and see if we can figure out what c is. So I have e to the -0.3 is equal to -1/2 times 1 squared plus c. 1 squared is just 1. So we have e to the -0.3 is equal to -1/2 plus c. So move my -1/2 to the other side. I get e to the -0.3 plus 1/2. That's my c. All right, so I'm going to take it back up. Oops, can you see that? There it is. So I'm going to take that back up to this step right here. I have my e to the negative y is equal to -1/2 x squared plus, and now I know what c is. C is e to the -0.3 plus 1/2. Now I need to get y out of the exponent because I need to rewrite this as y equals. So in order to do that, I'm going to rewrite this as natural log. I'm going to take the natural log of both sides. So if I do that, I get -y is equal to the natural log of all of this giant mess. So -1/2 x squared plus e to the -0.3. Oops, I have a hole in my paper. Plus 1/2. There it is. And now I need to get rid of that negative, so I'll move it over to the other side. Y is equal to negative natural log of negative 1/2 x squared plus e to the negative 0.3 plus 1/2. Okay, and hopefully that matches the answer that I have. I'm checking in Canvas. Is that what I wrote? I sure hope so. Whew. Yes. Only thing is that I changed the order of these when I wrote down the answer in Canvas. Okay, so that is the answer to question B, is solving the differential equation. But then for the next question, it says find the percentage error in your approximation. So if I've solved the differential equation, notice I have not evaluated this for when x is 1.3. So here's my differential equation, but I need to now evaluate it for when x is equal to 1.3. I need to figure out what y is. So y is going to be equal to natural log of negative 1/2 1.3 squared plus e to the negative 0.3 plus 1/2. So if I put that into my graphing calculator, because I don't seem to have written down the answer anyway nearby, so let's go ahead and do that. Excuse me, I have a cough. So I'm going to enter this in, negative natural log of negative 0.5 times 1.3, the quantity squared, plus e to the negative 0.3 plus 1/2, 0.5. Okay, and hit equals, and we get y is equal to 0.927 if I'm using 3 significant figures. Now we need to figure out the percentage error. So on part C, it says find the percentage error in your approximation from part A. So this is the exact value. And our approximation from part A, we had gotten y is equal to 0.825. Okay, this was the approximation from the Euler's method. So to find the percent error, so step C, percent error is you subtract these, so 0.927 minus 0.825, and you divide by the exact answer. Divide by the exact answer. Okay, and this formula is in the formula packet. So if you can never remember, which one goes on the bottom? Okay, look in the formula packet, it's in there. So if I do this now, so I already have my 9.27 in there, minus 0.825 gives me that, divided by, select it again, using all those numbers, and I get, for C, if I change this to a percent, it's going to be 10.98, but I want to round it to 3 significant figures. The 8 rounds up the 9 rounds up, and it ends up being 11%. There is my percent error. And question D, how can the error be decreased? How could we do a better job at this? Well, the exact answer is the exact answer, so we're not going to be changing that. But how could we get a better answer here? The only way we could get a better answer here is if we took smaller steps, if we changed our H value, if we made our H value smaller. So when I did this on the calculator, I had in here that my H value was 0.1. So if I change that to say 0.05 and do that everywhere I have that, where else do I have it? I have it right here. So 0.05. If I do that, do I have it anywhere else? I think that's it, right? Okay, and then I do second table. This always takes a second. And then let's see, what do I get? I get 0.8697. So if I make my H value, my steps, smaller, so instead of using 0.1, if I use 0.05, I can actually get closer. And I got here now, I got y is equal to 0.870 if I round that off. Okay, so this is what happens when I used H is equal to 0.05. So I'm getting closer to the actual value of 0.927. So if I can make my steps smaller and smaller, which is possible to do on the calculator, if you're doing the Euler's method by hand and using a table, which that's going to be really cumbersome and you're not going to want to do it. But it's super easy to do it in here. Again, I can get even closer. What if I change it to 0.01? So change that to 0.01. Those are my step values. And check the table. Let's see what happens here. So my 1.3, well, now I'm going to have to go find it. It's going to be farther down here. Because I'm taking tiny, tiny steps. My goodness. See, I didn't practice this. I didn't know how long this was going to take. It's making my video take forever. Anyway, I'm not going to say anything more after this. So if you want to stop watching, by all means, stop watching. I'm trying to get down to 1.3 to prove that I'm even closer to the exact value. So the smaller we make those H values, the step value, the more accurate my answer will be. It doesn't seem to matter. It doesn't, so the calculator is trying to calculate this. It's having a hard time. It won't let me like zoom down. I have to just hit it one at a time. Riveting video, isn't it? We're almost there. This should be it. Okay, so now I have 0.914. 0.914, oops, 914, when H was equal to 0.01. So 9.14, so I'm getting really close. Okay, so that's for letter D. Okay, make H smaller. The step value. Okay, make it smaller. All right, that is it. And 7A is in a different video.